As you get into your FlutterFlow app development journey, a common issue will invariably arise. You want your application to do something unique that the FlutterFlow team hasn't happened to think of yet, and therefore isn't available because you yourself have just thought of it. This is especially true if you're building something unique and innovative, because if you wanted to just build something that's common and vanilla, you could just use a SaaS. As I record this, it's almost 2025, and there is currently on the web more SaaS than there is porn. But don't worry, FlutterFlow has a slow and janky custom code builder to help you realize how much of a software engineer you really aren't. So to address the jank, they made things like the Visual Studio Code extension, and they're now making videos about cursor, and honestly, the message is confusing. Is FlutterFlow for non-coders or not? Here's my take. No code forces you to hope that the team building the no-code tool already knows what you want, eliminating the need to build it anyway because you would just use a SaaS. If you want to build something unique, or you just don't want the trade-off in flexibility that no-code forces on you, you need to code a little bit. But there's still a huge challenge around app architecture. And this is something that AI still sucks at, and actually no-code is actually pretty good with. Think about like the FlutterFlow login sign up, for example, and they're really quite seamless. And often it's just these little necessary things that you need to get out of the way so that you can enjoy building the things that actually make your app unique. So I advocate a hybrid approach, but as a software engineer, I wasn't willing to accept what was force-fed to me in terms of ways to create custom code, which basically always involves JavaScript. JavaScript is a language created in 1995 for the purpose of doing things we take for granted in a web browser, such as opening a dropdown or rendering an entire video game. In the 2010s came the JavaScript framework wars, then there was Node and Deno runtimes for running backend code in JavaScript, just so that JavaScript devs wouldn't have to bother learning another programming language. So when backends as a service like Firebase and Supabase emerged, they were like, whatever, JavaScript for cloud functions and everything else. The rich history of JavaScript led us to where we are, but one basic problem with this full takeover of the web by JavaScript that's never really gone away, is routinely ignored, and is what will get me crucified in the comments of this video is, JavaScript sucks. This is totally just personal preference, but Python is just such a beginner-friendly language, and it's yet really, really powerful, and I really advocate for it for working alongside FlutterFlow. Python is huge in terms of popularity. In fact, this year, it's been topping the surveys thanks not only to its awesome web frameworks like Django and FastAPI, but also for its unchallenged position as the language of choice for AI and machine learning. I've said all this before though, so this time I'm actually going to give you workable examples of how to deploy Python alongside your FlutterFlow projects and a few benefits to doing so. So your FlutterFlow application is always going to have a backend, and just because you're using Supabase or Firebase or BuildShip or anything like that doesn't mean you don't have a backend. It just means that you're offloading some of the complexity of backend work onto these companies in exchange for a reduced amount of flexibility in terms of what you can do on the back end. A lot of the time, what you will do is you'll have something like a cloud function, right? So you send, let's say you're creating an API call to the OpenAI API to do some AI kind of logic. So you send these instructions via this cloud function that you're still making a call to an API, which in this case is the cloud function in Firebase. And then that cloud function might do some kind of logic, and it might end up talking to the database as well, do a round trip, and give some data back to your FlutterFlow application. What I'm proposing here is that you exchange the cloud function in Firebase for a Python backend that you control entirely. And there's actually quite a lot of reasons why you would do this. Things like testing, logging, push notifications. You can create custom endpoints, you can do integrations with third-party APIs. Like, it's basically just anything at this point. When you have your own API and you control it, it's not just about writing a little bit of JavaScript code in the cloud function. You can actually create this entire environment, even in your development machine, and that is really easy to test compared to a cloud function. This way, your entire backend architecture is consolidated, and it's just much easier in the end to figure out what your app is doing, and it also increases the amount of flexibility you have in a huge way. This is FastAPI, and having worked with Python and different Python web frameworks for many years now, FastAPI is very much my recommendation. Some people sometimes worry about the performance impacts of Python, but actually being on a par with Node and Go, Node is the JavaScript runtime, and all of the work that the Python team have put into performance in the last couple of years, especially in version 3.11 and 3.12. We're in Python 3.12 at the moment. Honestly, that's not really a concern anymore if you ask me. But Fast API simplicity is also a huge draw for it, and that's actually what I really like about it. It really does just making backend APIs easy and intuitive. The other key tool that I want to introduce you to is Poetry, and Poetry is for dependency management. It helps you orchestrate your libraries in your Python project really easily. So once you've gone ahead and installed Python for whatever operating system you're using, Windows or Mac or Linux, then you just need to follow the instruction guidelines for Poetry as well for, again, whatever operating system that you're using. Now, even if you don't consider yourself a coder, I still recommend, regardless of what operating system you're using, to get to know the terminal just a little bit, because you can do things in the terminal that ultimately end up making a lot of sense and really, really save you a lot of time. In this case, I'm going to run Poetry install. And what it's going to do is it's going to install all of the Python libraries that I need in my Fast API project. Here's what this kind of project looks like. This is an actual API written with Fast API. In this pyproject.toml file, you'll see all of the different dependencies you might need. And you can absolutely put this kind of thing together yourself, but I will provide a link in the description as well for some resources to get you going. And your API does not need to be as complex as this. I just have a lot of stuff in here that I've been accumulating over the years. Things like exception handlers, advanced logging, just things for production APIs that you can add incrementally as you go along. You could just have a very, very bare bones app if you wanted. In Fast API, you'll generally have this app folder, and you'll start maybe with a settings module. And this settings module is going to house the different environment variables that you need. And this can be simple things like app title or whatever, but also for FlutterFlow, for example, I use a deep link URI. That's for push notification deep links. I also have my Supabase secret keys in here. I have my Firebase configuration. I have Cloudinary, which I use for media, for video and photo uploads. Also things like Stripe and Resend is the email service that I use. Now everything starts in Fast API from a main.py file. And again, there's a lot of stuff in here that you probably don't need initially, but this is what a production API looks like. I try to be as minimalist as I can, but there are some things that just have to go in here. So for example, I have exception handlers. One thing that I can do, if there's an error in a Cloud function, it can be really difficult to debug. But I've just written this little routine, and what it does is it sends a message to my Slack channel whenever there's an uncaught error. Whenever there's an error that I wasn't expecting, I actually get a notification about that. And that can be really helpful if there are errors happening all the time. I don't know about them unless I'm getting a notification. I've actually configured Slack to send me errors, which is really, really useful for getting to the bottom of a problem and seeing when it occurs. And speaking of logging, I've actually done some more advanced things with logs. For one thing, I've actually just added colors, which isn't something that you get by default with most frameworks. So now if I have a warning in my logs, it's going to stand out in yellow. If I have an error, it's going to stand out in big red. This actually saves me a huge amount of time. And I can also set up things like debug in info. So if I'm working on the project actively, I'll set the flags to debug and I can see exactly what's happening in the logs. For production, I'll set it to info. And for testing, I can actually also increase it because maybe I don't want to see as much logs in my tests. And that brings me to another really important point is testing. And with Cloud Functions, and I think you're probably not testing your applications, are you? You're just writing Cloud Functions and hoping for the best. This is a very common thing. I mean, honestly, I'm not even experienced with testing Cloud Functions. I'm sure that there's a way to do it. I'm sure that most people are not doing it. The thing is, your application will be absolutely full of bugs if you're not writing tests. So let me give an example of what I do in terms of testing. It doesn't have to be anything super complicated. In this particular project, I'm still using Supabase. I'm not suggesting that just because you have your own custom backend that you even need your own custom database. Very often you probably want to use a managed database anyway, just for security and for simplicity and for fault tolerance. So what I do is in some cases, I'll actually just send the request that would normally go to Supabase through my Fast API endpoint. There's one or two reasons that I do this, one of which actually is because I don't use Supabase auth. This is the huge problem with FlutterFlow because push notifications don't work because device tokens don't get saved in the right places when you're using Supabase auth. So I want to use Firebase auth. I want to store my device tokens actually in Firestore, in the Firebase database. But I use Supabase as my main database because I want the SQL abilities that it has. So what I'm doing here, this is actually just an example. So all of my entities are called items, but it could be like bookings or Stripe payments or whatever entities you're using. You're going to have a whole bunch of tables and a whole bunch of fields. This is just an example. So this endpoint is actually just formatted the way you would format a request to Supabase with this REST version 1 path and then the name of the table. And you can also add headers. So you can actually do a lot of things with Supabase. Supabase is based off of a library called PostREST. And that's like an API layer over Postgres. And Postgres actually has a lot of really useful things that it offers that might not be as obvious if you're just using Supabase and just using the documentation. For example, if you add this header to an API call and you know you're only getting one result, it will just give you that one result instead of a list or an array of those results, which can be a real pain sometimes. There's a lot you can do if you go to the Postgres documentation and have a look through it. Anyway, here's where Python and VS Code get really magical. Once I've got my tests set up and I'm in the middle of development and I'm writing new tests as I go along, I can actually apply breakpoints in VS Code. So now when I run this test in VS Code, it's actually going to stop at the breakpoint. And I can even use these arrow buttons to go into the functions or into the endpoints as it's running. So I can just iterate forward along the way. And whatever I'm doing, wherever I am, I can just shove variables into the debug console down here, and it'll tell me exactly what that variable is. I can even actually just write Python in here. So in this case, I'm passing things through using test data and test users into this Supabase function that I've written. This current user, for example, this is my test user. I'm just calling myself IAmAdmin, but this is just test data. And then I can just keep diving into these functions and seeing what they're doing under the hood, which is really, really useful. Anyway, in this case, I've got a whole bunch of CRUD, that's create, read, update, and delete endpoints that I'm able to explicitly test and see what's going on in every line of code. So it's really good to just run your tests periodically. And what I've done is I've actually set up a local Supabase environment so that I can actually run these things off of a real Supabase database. And that gets more towards an integration test than a unit test. Although you should have different kinds of tests. I find if I'm only going to choose one, these end-to-end tests, they're a little bit harder to write, but they are super useful. So there's a bunch of other things that I've already written into this Python API. But really the whole beauty of it is that you can write whatever you want and you can analyze everything that's happening in your API, in your development environment without ever having to touch production. I mean, for example, I'm using these Supabase endpoints here. I have written these myself, but if you wanted to do more custom endpoints as well, you could just do that as well. I've got a sample route here, just get the items of whatever they are. And unlike with other systems, you can just dive into these endpoints, you get the input data, and you can just type whatever logic you want and then return the output again. So the control and the flexibility that you get is absolutely massive. By the way, if you're enjoying the content, please consider subscribing and drop a comment to let me know what you think about this approach. Even if you're just a diehard JavaScript dev and you just want to flex, no judgment. Now, I do also want to mention some FlutterFlow specific things. And one of the things that annoyed me about FlutterFlow for a long time was that you couldn't really integrate Supabase with Firebase and still get push notifications to work. And even if you weren't using Supabase, there were still issues when it came to badges and sounds and just things that are normal with push notifications that you should be able to do, especially and deep linking as well. And things have gotten better since I first started using FlutterFlow, but all the same, using Supabase, for example, made push notifications break, and it was really difficult to consolidate them both. And my solution was to use this Python backend to do it. You see, because the Python API is a totally secure environment, all you need to do is add your credentials for Firebase and also Supabase if you want into this secure environment, and then you can just use the SDKs. So for example, if I have a list of users that I want to pass in, what I can do is I can actually just grab all of the users from Firestore inside of this backend and grab all of the tokens that are associated with that user. Tokens are what your device sends out that gets saved in Firestore so that SCM, the Firebase Cloud Messaging Service, knows that your device is going to receive a push notification. And those are stored in Firestore. You might not even notice them. They're in a sub-collection under the users. So what this code does is it dips into Firestore and it grabs the tokens for you, and then it sends the push notifications in whatever way you want. So you can just configure this however you want. And you could have custom sounds, custom pings for push notifications, and you can add badges, which is really important in iOS because they just don't work right with FlutterFlow out of the box in terms of iOS. They're fine with Android. And deep links are a really big deal as well, because if there's no deep links, the user is going to be tapping on the push notification and it's just not going to go anywhere. It's going to go to the home page, for example, which is really bad UX. And it's these kinds of things that make people say that FlutterFlow isn't as good as, working natively. Whereas the truth is, it just has these little limitations that can be overcome by custom backends. I've also been able to do a lot more stuff since using Python in terms of user authentication and in terms of user authorization. Because since I have access to the SDK for Firebase, what I can do is I can take the token directly from FlutterFlow and I can add something called custom claims to it. And custom claims, they're just a little bit of text, but they're totally secure because they're embedded in the token and the token is signed. So all I have to do is I have to say, hey, are you an admin user already? Okay, cool. You are eligible to make a new admin user. So all the code is doing is it's just setting a custom claim with this set custom user claims method. And now an admin can create another admin. Of course, you need to tweak this logic a little bit to create the first admin, but it's the same process. And now that you have an admin, what you can actually do is set up different kinds of, there's one thing you can do is create RBAC, which is a role-based access control. And you can do this in Supabase. You can do it in row level security. You can just add this custom claim to the token, give it to Supabase, and say, hey, set up this ORLS policy, which dictates that if this user is an admin based on this custom claim within their token, then give them admin privileges and let them go and use the admin endpoints. And you can just write admin endpoints in this custom backend, and you have this whole admin system. So what this actually means is that I can do things like set up an admin panel, and that's what I've done in this case. So I have this, it's actually a Vue.js, it's a JavaScript application, but it's baked into the API. It's just a bunch of HTML and JavaScript that's being served by the Python API. And I've written it in such a way that I can actually access different database entities and mess around with them. And there's a couple of reasons why this is useful. For one thing, it's very extensible. But for another, I can have things like terms and conditions pages, right? So I can just update the terms and conditions. I could give this to an app admin, even if they're not a programmer. And then once these things get updated here, they get served by the API itself. So the API is just another endpoint, and it's, in this case, serving a simple HTML page. And what you can do is you can embed this into the app. And not just that, though, it's a web link. So you can actually give it to the app stores. The app stores insist that you have a terms and conditions and privacy policy link, as well as data deletion, which I also have in here. And so now the API just takes care of this for you. There's no need to set up a website at all. In fact, if you wanted, you could set up a landing page for your app and just have it publicly accessible, and it would all just run from the API. And of course, I also do things like manage my Firebase users and that sort of thing, so I can make people admins just from this dashboard. Okay, but John, that's all wonderful and magical and everything, but how do I put this online and into production? Well, I've used a lot of providers, and there are a million to choose from, by the way. But my top pick, and the one I recommend, is fly.io. Now, if my mention of the terminal has scared you off beforehand, don't worry, there is actually a GUI with fly.io. However, it really does become ridiculously easy when you start just typing a few commands into the terminal. Because all you really have to do is do fly login, and then you can do things like fly launch. And once you're already in your repository folder, you just type this into the terminal once you've installed the SDK. And you can, it'll take you back to the browser, and you can tweak a few things. You can put the region, the organization, and what you want to name your app, what the internal port is. Like, for example, with FastAPI, you have an internal port of 8,000, so it's already set to that. And you can actually scale up and down the machines. And one really cool thing about Fly.io is that if it's turned off, it actually works like serverless. You can just scale it down to 0 and it won't cost you any money. Because I'm working only in development right at the moment with Fly.io, I have literally paid 60 cents for this month in bills. But if your app gets bigger, then all you do is scale up the machines and the number of machines, and you're good to go. It's really, really easy stuff. You would also add environment variables, which you can do really easily from the dashboard. You can also do it from the terminal. So I just go to the app that I just created, and I can go to secrets. And whether or not they're a secret, they're just environment variables. And I find this so much easier to reason about anyway. You just add like your API keys for OpenAPI, your Firebase credentials, all these things, you just send them up to secrets. It literally takes about 5 minutes to set up. And then once you're set up, all you have to do subsequently is hit fly deploy, and it will just deploy to an API. And then it will tell you the URL of the API. I think if you're not super experienced with the cloud and you just want something that works, Fly.io is really, really nice. And so once that's deployed, all I have to do is head to, in this case, one of my client projects is called MagicWork. And I have this here at magicworkapi.fly.dev. That's the URL that Fly.io gives you. So I got my dashboard working. I also have automatic documentation. This is something that FastAPI gives you for free. And so you can see all of your custom endpoints. These are all endpoints that I've written in this API. You can even try them out. You can set up authentication. I just have to put my bearer token in here, and I can try out any of these endpoints. So you really do get a lot for free with these Python endpoints, especially with FastAPI and especially with Fly.io and Poetry. And they're my preferred workflow, and they save me so many headaches day to day. I'm actually working on a starter kit that incorporates all of this so that you don't have to code it from scratch. So push notifications with deep links and badges and the admin controls and the admin dashboard, the Supabase token minting and the Firebase auth and a whole bunch of other features. in a very simple template that you can just smash up on fly.io in very little effort. It's not quite ready yet as I record this, but it might well be available by the time you watch it, so visit the link in the description to check it out. Anyway, hopefully that provides at least a little bit of insight into how you might go about integrating a Python API with FlutterFlow. And if you want to learn a little bit more about how this architecture works and how it can integrate with Firebase and Supabase, check out this video as well. Thanks for watching.